channels. Let's see if I can find it on my computer. Let's call this Calc Integral by parts. Alright, it's a little delayed, but that's okay. Alright, where's the link to this? Just got text. Where's the... No, where's the link to this? I don't know what I'm doing here. There we go. Okay. Yes. I will be starting in 1 minute. I'm going to go over a couple of the sample problems. Particularly looks like I'll probably go over... give me a second, let me mute myself. And let me see. Just want to check. I'm probably going to do the first 6 sample problems, and I feel like then the first 6 I ask you to do covers with the first 6 sample problems. Or for sure I'll do at least the first 4. Did we do that one? Or I think we did that one. Okay. Alright, so let me start off. I'm going to do 1 through 6 in the sample problems. Once more, I'm just going to say that. Your homework is going to be the 1 through 6 on the practice problems. Now, the 1 through 6 on the practice problems, as I look at it right now, in terms of samples, you probably only need to see 1, 2, and 3, and 4. You're not going to be using arc sine or arc cosine, which is inverse sine, in the first 6. So definitely for the 1 to 4, pay attention, and if I feel like it, I'll do 5 or 6. If not, we'll leave that to tomorrow. If we still got time. I don't want to hold you up for too long. Okay, so the first one's x e to the x dx. Oh, actually, before I start, I asked you guys to watch the Kudos or Khan video, and they talk about the equation. What's really important about this equation, which is right here, is that this is the inverse of the derivative of chain rule. So this is the backwards. So it's kind of like the antiderivative of chain rule. Now, when you first look at it as an equation, you're like, how does that make it simple? You just put 2 integrals now instead of the one you started with. And what I have on the left is with u and v. I'm going to stick with the f of x and g of x, just simply because I don't want to get confused with u substitution. So I'm going to use the f of x and g of x, but you might see on here on other material if you look into it. So, number 1, x e to the x. So here is your first goal. Your goal is that you got to identify what f of x is. Let me do it up here. You got to identify what f of x is, and then you will find x prime. And then you got to identify what g prime of x is. I'm going to call that g of x, and I put g prime of x here. Now, the way to select what your f of x is and your g of x is very simply, when you look at your f of x, you want something that makes your derivative get smaller. Or your derivative gets, when you derive it, it gets smaller, easier, simpler. Typically like a power. So if I'm looking at question number 1, I'm going to decide that my f of x is this one right here, which is going to be x. The reason I chose x is because when I do x prime, it'll just become 1. And that's really good for me. I wanted to reduce the x prime. Now over here, your second one, your g of x, should be something that when you use the antiderivative or the integral, you get something that's, you would love it to be simpler, but that usually never happens. So you just satisfy with not more complicated. So you'll take not more complicated instead of simpler. F of x should always get simpler. G of x, you just settle for not more complicated. So e to the x, when you antiderive that, that's again e to the x. So this would be like the most basic chain rule or integral by parts problem. Okay, so let's follow that equation on top. F of x, g prime of x. So that's literally what this equation is going to equal f of x, g of x. I already identified everything for myself. So f of x is x, g of x is e to the x, minus the integral. And let's keep going. We have f prime of f of x. So we need the f prime, which is 1, times the g of x. So that's that antiderivative we found earlier, which is e to the x, dx. Okay, well that's really nice. 1 times e to the x is the same thing as e to the x, so I don't really need that. And then that e to the x dx is going to get, we know the antiderivative of e to the x dx. That's just e to the x again. So what we have is x e to the x minus e to the x. And we would be done, you just got to include the plus c. So there's like I would say like the textbook example of what integral by parts does. And how does it actually make it simpler? Because basically from the formula, I can understand you look at it, you're like, how does this make it any simpler? Okay. Now, typically when you're choosing, you want to choose ones that are going to, f of x derives to a simpler equation. So I'm about to erase this. Then we're going to go to number 2, which is the integral of x cosine of x dx. This is number 2 in the sample problems. Okay, so again, I have to decide my f of x, which will lead me to find f prime of x. I need to decide my g prime of x, which will lead me to find g of x. Okay, as most of the time it's going to be something that is a power rule. So x in this case is going to be the simple one to be reduced. So x, I'm going to rewrite that, or this is x, and then the derivative of x is 1. Cosine of x, well, it's still, you know, it doesn't like clean itself up, but it's still as complicated as it was before, because the antiderivative of cosine x is, please remember, positive sine x. So we got f of x equals x, f prime of x equals 1, sine x of g of x equals sine x, g of cosine x. So I would say the first difficult part is just identifying which ones have to be f of x and g prime of x, and then working from there. All right, so this is the equation here. So this is going to equal f of x, g of x. So x cosine x minus the integral. Now we got f prime here, which is 1. I'm not even going to bother writing that anymore. Sine x dx. So it's 1 times sine x. I don't need to write the 1. Okay, so now I know what the antiderivative of sine is. If you know, the antiderivative of sine is positive cosine. Or, I'm sorry, the antiderivative of sine is negative sine. So we're going to make it x cosine x minus negative cosine x plus c, double negative, that just becomes a positive. So I could just rewrite that final part as plus cosine x. And I apologize, I said positive because I was skipping ahead. Yeah, you could take out a cosine here, but it doesn't really simplify it, because what basically happens is that c is always there. So like, you never really want to take out anything. It doesn't really solve anything. So you're just happy here. You don't need to factor out the cosine. Okay, so number 3 is tricky. Or not tricky, but it's what makes integrating by parts hard. You can pause the video here, and I'm about to erase it, and you can catch up later if you want to look at it. So, number 3 is x e to the negative 4x dx. Okay, well, you know, I'm getting used to this. So f of x is definitely x, where f of prime of x will be simpler, is 1. And then we have g of prime of x equals e negative 4x. Well, I need to find the antiderivative of g of x. Now, it's not e to the x, it's e to the negative 4x. So we got to remember, either you're going to have to do substitution rule, or I believe we gave you a rule for e, or the exponents. So I'm just going to tell you the rule for e to the exponents. Basically what happens is this is going to be moved here. So what happens is that the derivative of this is going to be e to the negative 4x over negative 4. And I just want to think in my mind, is that correct? E to the negative 4, I just want to make sure. Yeah, so it's negative 1/4 e to the negative x to the 4th. So I just brought the negative 4 and put it divided by here. And that's not very clear, so I'll just, when I rewrite it here, you'll see it. Okay, so let's continue. So f of x, g of x, that's the equation I pointed out. That's going to equal f of x, that's just x, times g of x, that's e to the negative 4x over negative 4. If you don't remember, you just take the k and divide it to the e of the x. Minus this integral, f prime of x, which is 1, so I'm not even going to bother writing that, and g of x, which is e to the negative 4 over negative 4 dx. Oh, there's an x up here too. Okay. What's really beneficial is I could take this negative 4, and that's a constant being multiplied. So I could remove it here and rewrite this part as, this is negative negative, so that's positive, plus 1 over 4 times the integral of e to the negative 4x dx. Wait a second, I actually already did the work for the integral here. If you don't remember, you take the k and divide it here. So it's 1/4 times the integral of this is e of the negative 4x over negative 4. Not dx anymore, because it's just been integrated. And then those two things multiplied here is going to become e to the negative 4x over negative 16. So now I'm going to put this along with this. So this guy never really changed, so he's going to go over here. And he's just x e to the negative 4x all over negative 4. This is end up being minus, because over here we ended with a negative. So that's going to be minus e to the negative 4x over 16. You could say, Mr. Tobel, do we need to make it simpler by doing common denominators? I'm going to say no to that. Don't bother with that. That's not necessary. All right. So I'm going to go to number 4, ln x. So ln x is a very interesting one, simply because you have to think a little bit differently. Okay. All right. So I'm going to erase this. If you have any questions, you could type into the chat. I'm just looking at that. And if you need me to stop or go over anything, I'm happy to do that also. I'm probably also going to do at least 1 or 2 of the homework problems. just to make sure we get that under wraps. Okay, so we're with what looks like a very innocent integral, ln x dx. And you look at it, you're like, there's not much going on there, Mr. Tobler. It's just ln x dx. The problem with this one is, I want to figure out a way to make the ln x disappear. Because I don't know what the integral ln x is internally. And I can't use u substitution, because even if I u substitute that, it doesn't really work. So I got to figure out something to do with this. So what I'm going to do is I'm going to rewrite this very interestingly. I know, or I guess there's always the fact, this is technically always times by 1. This is technically always times by 1. So what I'm going to do is make ln x my f of x. So f of x equals ln x, which is pretty immovable. Oh, Amber alert. Sorry about that. So that's ln x. So we're going to take the f prime of x, and we're going to dilute this. And if you don't remember what the derivative of ln x is, that's 1 over x. So if this is f of x and this is f prime of x, this is left to being g prime of x. So g prime of x equals 1. Well, the other 3 problems, you should know already what the antiderivative of 1 is. If you don't know, think of it as x to the 0 power. So then you could turn it into x. All right, so now we have our actors here, and we're going to put them into play. So let's fill in their roles. F of x, so that's equals f of x, so that's ln x. G of x, that is x, minus the integral of f prime of x, which is 1 over x, and then g of x, which is simply x, dx. Okay? Wait a second, we have an x on the bottom, we have an x on the top, we could cancel these guys out. That's really nice. So now we're just left with minus the integral of 1 dx. Well, we kind of already figure out what the integral of 1x dx is. That happens to be minus x. Here is ln x times x, so I'll rewrite it like this, x ln x, minus x, don't forget your plus c. I'm going to look back at the live stream to see if I forgot it. Maybe I did, maybe I haven't. And that's it. So the integral by parts is it's a complicated equation, but it's not that bad after you just set it up and dissect it. Now, what is annoying is one that we have, which is number 6. So I'm going to do number 6. Is that the practice problem? Yeah, practice problem number 6. So I'm going to do practice problem number 6. And if you're watching, you don't have to, or you should write along with it. Yeah, sure. Let me do that now, Nava. Or Nizzle, my bad. Nizzle 100. So the equation is, and I just want to make sure I'm keeping consistent, because sometimes f of x and g of x get swapped. F of x, g of prime of x, is going to equal f of x, g of x, minus the integral of f prime of x, g of x, dx. And if you want to know where that equation comes from, I recommend watching the Khan Academy video. If I were to do a video, it would be literally repeating what he says. So there's no point in me making a second video of it. But good question is. Let's go. We're at number 6, x squared, 2 to the x power. So let's write that down. X squared, 2 to the x, I wrote e, 2 to the x power, dx. And usually, it's very, I should say, it should be clear that it's very easy. Should I say easy? It's typically the one that you want to make the f of x, the one that you want to simplify, is a simple power one, so like x squared. So we're going to do that and make that the x squared. And I just want to pull up the answer for the practice because I don't want to mess up this one. Okay, it looks like I know what I'm doing, I think. Or should I use 2 of x? All right, so we're going to do this one. So I'm going to make this one f of x. And I'm going to make this one g prime of x. Okay? So x squared is f of x. So f of x equals x squared. F prime of x equals 2x. Okay, pretty simple. We're reducing it. G prime of x equals 2x. Now the integral, and I just want to make sure because we haven't done one with a base of a number in a while, so I just want to look it up so I don't mess it up. 2 to the x. I apologize. How do you want me to show this one? I'm deciding, should I just show you the quick rule or should I just show you the whole proof to it? I'm just going to show you the quick rule. The quick rule, so we're going to put this on the side. The quick rule for the integral of some number, I'll call it b, to the x power dx. So you want to write this down as a side. You might want to put this in your integral rules back in section, I think it was point 1 of this chapter. If this is chapter 6 or 7, I don't remember. It is going to be b to the x power over ln b plus c. So I would copy down that equation right there. Maybe what I'm going to do instead, integral b to the x power dx equals b to the x power over ln b plus c. So I could put that on the side, like right there. And I'm just going to keep that up. I can't really keep it on the screen. And I'm going to need a space, so I'm going to erase that soon. So just copy that down. Okay, so let's go from here. So, as I said, is b to the x, so then that is g of x equals, and all that gobbledygook, which is 2 to the x power over ln 2 plus c. Okay? And we don't need the plus c right now, okay? So we'll just put 2x over ln 2. Okay, so let's do the equation, f of x, g of x. So this equals f of x times g of x, so x squared times 2x over ln 2 minus the integral of f prime of x, which is 2x, times the integral of g of x, which is 2 to the x power over ln 2 dx. Okay? Well, ln 2 is some number. And if it's some number, that is some constant. So because this is a constant, I can move it out to the front. So I'm going to rewrite this as negative 2 integral, negative 1 over ln2 integral 2x times 2 to the x power dx. Now here's my issue. I still don't know how to integral that. So what this causes, and this is why number 6 is a really hard one, so that's kind of why I chose it, is that you're going to have to do another, that's right, another integration by parts, just to reduce the 2x. So now I have to do a second integration by parts. So I'm going to call f of x, and I got my g prime of x. This f of x is going to become 2x, and I want this one to be f of x, because I know it's going to reduce down to a constant. And when I can reduce it down to a constant, that means I can move it out of the integral and it stops being complicated. And we already did g of x is 2 to the x power. G prime of x is 2 to the x power. So g of the x should be 2x over ln 2. So now we're going to have to repeat all this again for this integral. So I'm going to keep that minus 1/2 ln here in the front. Put a big parenthesis. And the equation, if we were to look at the top, and I'm sorry how the shadow lands, actually. Let's see if I can, maybe that helps a lot. There we go. So we have our f of x, g of x. So that's 2x, and then g of x, which is again 2 to the x power ln 2, minus the integral. Now the integral is going to be f of x, and we look at it, f prime of x, I should say. So that's 2 g of x, which is 2 to the x power over ln 2 dx. Close parenthesis. Well, this is a constant, and this is a constant, so I can move these guys out. So I have 2 over ln 2 integral 2 to the x power dx. This is our third time integrating 2 to the x, or finding the antiderivative. So this final piece, 2 times ln 2 times 2 to the x power over ln 2. So this all here, it's the final integral. Now there's no more integrals. So I'm going to rewrite my whole answer as one big line, starting with this, which, you know, he's been hanging out, doing nothing. X squared, I'll just put it like this, 2x over ln 2 minus, okay, so minus, we're going to have to take care of these guys. So that is, let's see, 2 to the x, 2x, 2 to the x, interesting enough, over ln 2 times ln 2 is ln 2 squared. And I think if you have an exponent in a log, you can move it in front. So that becomes 2, and that disappears. And if that disappears, and we have a 2 and 2 here, I believe you could cross that out. I'm just going to check the answer before I say something incorrect. And I wish I could teach this one in class, but, you know, coronavirus kind of sucks. It'd be nice to actually talk about it in detail. Oh, they factor out a 2x dx. Oh, no, because it's ln squared, so I can't do that. So let me just rewrite that as 2x 2 to the x over ln squared 2 squared. It's kind of like sine squared versus sine 2 squared. So that was my mistake. So we took care of that. And now we got to take care of this guy. So that's a minus also. Well, it's a double minus if I'm distributing this guy here. So it's going to be a plus. So we have on the top 2 times 2x. So we have the top in the numerators, 2 and 2x to the x power. Over, we have, let's see, we have 1, 2, 3 ln 2. So ln cubed to the second power. I'm sorry, ln cubed 2. Oh, that's a lot of junk. Okay. Don't forget your plus c. If we were doing this in class, I would ask you to stop here. The answer sheet that's given to you guys, they factor out all the 2x's, and they factor out at least 1 ln 2. I'm not going to expect you to do that. I don't need you to do that. You integrating or getting this far is enough for me. I'll stay on for another 10 minutes if you want me to go over some questions of the practice problems. And I'll just stay on the live stream. Just type them out if you need them. Otherwise, I'm done with what I wanted to cover today. Tomorrow, we're going to do more integration parts. The next day, we're going to do more integration parts. And maybe the day after, Thursday, we're going to do more integration with parts. This is a topic that if we were in school, I would take 3 days to teach. So being out of school, it might take a little longer. It might be a little, I don't know how it's going to work out. So I'm still figuring it out day to day, so we'll see from there. Again, if you have any questions, this work is right here. And if you need me to pause, or you need to pause to like get a clip of this, go ahead. All right. I'm going to erase all that. And then I'll take any questions. Oh, I'll take any questions. So number 6 on that homework, it is a tough one. It was going to require 2 of them. I realized none of the sample problems I gave 2 of them. And I don't know if the Khan Academy one I showed gave 2 of them. I have to look at the list I gave out. The homework is going to be till tomorrow noon, because for 12th grade, my live stream, the math live stream day, is very late in the day. So it's unfair to make it due 7th, like 7 p.m. like most of the classes. Oh, they did have one next. Yeah, I did some of them twice, I guess. It is what it is. Hey, no problem. No problem, there's a 100. Alright, I'm going to end the live stream. If you have any questions, happy to email me. Remember, take a picture of your work and submit it to Google Classroom, okay? All these sample problems that are on that page have the worked out steps. What I'm going to be doing is just actually talking about the worked out steps and try to give my inflection onto it. Otherwise, keep clean, wash your hands and all that. Have a wonderful day and take the time to your advantage.